Simultaneous equations can also be used to solve for equations where non-linear functions are involved. So we've looked at examples that involve the intersection of two straight lines. But what if one of the equations represents a curve of sorts? Let's have a look at this example. Solve simultaneously the equations y equals 3x plus 1 and y equals x squared plus 2x minus 5. Let's think about it graphically for a moment. Y equals 3x plus 1 is in fact a straight line. So, and it's a line with a positive gradient of 3 perhaps, will look like this. Y equals x squared plus 2x minus 5 is a parabola. So it's a U-shape. It's actually a concave up parabola. So it might be something like this. And in actual fact, we're solving for the points of intersection of this straight line with this parabola. Now we'll have a look at it on the graphing calculator later on. So let's just solve it algebraically for now, and then we'll have a look at the graphical solution as well. Okay, so we can use actually either elimination or substitution method. It's probably best to use substitution method since we already have y as the subject of both of these equations. We could eliminate the y variable. That's that law of transitivity. You know, if left-hand side equals this right-hand side, but the same left-hand side equals a different right-hand side, well, it stands to reason that both right-hand sides must be equal to each other. So x squared plus 2x minus 5. Okay, I'm just going to sort of write them back to front. So sort of reverse the left-hand and the right-hand sides. And then the linear equation, so 3x plus 1 is equal to y. So since the same pronumeral y, they're not two different y's, they're the same pronumeral y, is equal to both of these left-hand sides, so the two left-hand sides themselves must be equal to each other. So x squared plus 2x minus 5 must be equal to 3x plus 1. Now we'll move everything over to one side, so looks like we're going to get a quadratic equation of some kind. So x squared, so subtracting 3x from both sides, we get negative x. Subtracting 1 from both sides, we get minus 6 is equal to 0. Of course, we can factorize this, so you're going to end up with a negative 3, positive 2. Okay. Negative 3 plus 2 gives you negative 1. Okay, therefore, hopefully you can see that. Okay, I'll try to write these in some sort of order. So x is equal to negative 2 or x is equal to 3. But that's only half the solution. Okay, we need the y values as well. Remember that we're dealing with coordinate geometry here. Solutions of simultaneous equations, it's actually a solution set. So we're talking about xy pairs or coordinate pairs. So we've got the x coordinates, but we now need the y coordinates. And we can use probably this equation here, equation number 2. Okay, probably should label these. So let's call that equation 1, equation 2. Let's use equation number 2 to find the y values. So when x equals negative 2, okay, we have y is equal to 3 times negative 2 plus 1. Okay, so negative 6 plus 1. Actually, I'll just see if I can fit it there. Yep, is negative 5. Okay, so that's great. And what about when x is equal to positive 3? Okay, we have y is equal to 3 times positive 3 plus 1. Therefore, y is equal to 10. Now, we can substitute these values into the original equations to test left-hand side equals right-hand side. If this was an exam question and you have a little bit of time, you should factor in, 10 seconds or 20 seconds of time just to check your solution. I'm not going to do it in this video. We're just going to assume that's already been checked. Okay, so therefore, the solutions are, and there's going to be two sets of solutions. We have negative 2, negative 5, or, okay, we've got 3, 10. Now let's have a look at this graphically. Okay, I think it's well worth seeing the graphical solution to this. So I'm just going to use the graphing calculator again, and need the stylus for that one. So what I'll do is I'll type in the equations. So 3x plus 1 and we also have the quadratic, that's x squared. Okay, so x squared plus 2x minus 5. So I'll tick both of those and I'll graph those equations there, and I'll just maximize the screen. Hopefully, yep, you can see that. All right. So for the calculator, just to update. Yep. So we can see the red curve here is the parabola. That's the y equals x squared plus 2x minus 5. And obviously the blue line is the linear equation, y equals 3x plus 1. Okay, and we can see that that's one point of intersection there. I'll just zoom in a little bit there so you can see that. Maybe once more. There we go. Okay, so we can see 3, 10 is definitely one of the solutions. Okay, and -2, -5 is another solution. So these are our 2 points of intersection. I could use the calculator solver, the graphical solver tool, to find the point of intersection. So there you go, there's one there. Hopefully this works, and there's the other one up there, 3, 10.